Hi, in this video I'm going to walk us through Classification of Matter Day 2. The vocabulary that will be especially important in this presentation includes pure substances, mixtures, elements, and compounds. For review, now that we've gotten the hang of atoms, molecules, and particles, we're just going to use shapes and colors to represent atoms. How would you label number 3 and number 4 where there are question marks? There's our question mark for number 3. There's our question mark for number 4. Similar to our presentation yesterday, this sheet is using T, SQ, and R to represent our atoms. So take a moment to think about what letter you would use to represent the atoms here in box 3. The letter I would use would be T. T would stand for triangle, and that would make sense, given that box number 2 also contains T and has these purple triangles. How about box 4? Take a few moments to think about what would go for box 4. If I look at the particles in box 4, I see there's only one type, and each type has 3 round shapes and 1 square shape. So as I name this, I'll probably want to say SQ for square, but then next to R, I'm going to put 3 because every particle has 3 round shapes. For us, it'll be important to know the difference between pure substances versus mixtures. Draw a P next to the words below that you think represent the word pure, and draw an M next to the words that you think represent the word mixture. At first, let's look at these 3. I'll give you a couple of seconds to think about whether you would draw a P or an M next to those words. For original, I don't think that original represents pure or mixture, but if I had to pick one, I would say it sounds much more like a P than it does to an M. For our second word, one, if I only had one thing, that would make it pure instead of a mixture. And then for genuine, probably going to use the same strategy as I used for original. I just think that it sounds more like pure than it does mixture. Okay, next, let's look at these words. Take a few moments to think about whether you would draw a P or an M next to the words. So hodgepodge sounds to me like a mess of things. So if it's a mess of things, I would probably say that's close to a mixture of things. If I put 2 things together in a combination, it sounds like I would have a mixture. If I was to jumble things up, I would put things out of order, and that would mean I probably have more than one thing. So I would put M next to jumble. For only, that kind of makes me think about having only one type of thing, which reminds me of the word pure. And then many, if I had many things, I think this could go either way. If I had many of the same thing, that would be pure. But if I had many different things, that would remind me of mixture. So matter is classified as a pure substance when all of the particles are identical. Matter is classified as a mixture if there are different types of particles present. So here are our words. We want to draw attention to pure substance. We want to draw attention to mixture. In pure substance, all of the particles are identical. In mixture, there are different particles present. Now let's think about how this should work with pictures of particles. Let's circle the one picture that shows a sample of a mixture. Between these 6 diagrams, take a moment to think about which one you would circle that shows a mixture. In picture 1, I can circle this to highlight that every particle in that sample is the same. They're all orange round shapes. I can do the same thing with picture 3. All of the particles are single purple triangles. In 4, all of the particles are 3 orange circles stuck to a square. In 5, all of the particles are 1 orange circle stuck to a square. And in 6, 2 squares are stuck together. So the one picture that represents a mixture would be picture 2. I can see that this picture contains both single purple triangles and orange circles and orange circles bonded to squares. So it is a mix of 3 different types of particles. Here's another question. How are the codes or chemical formulas of pure substances different from those of mixtures? Let me highlight the codes for each picture. So in picture 1, the code is R. In picture 2, the code is T and RSQ and R. In our first slide of this presentation, we said that the code for number 3 would be a single T. Also in that first slide, we said that the code for picture 4 would be SQR3. The code or chemical name for 5 would be RSQ. And the code or chemical name for 6 would be SQ2. In a previous slide, we said that 2 represented our mixture. And it looks like the code for 2 is different because it contains the AND symbol, and the other codes do not. So it appears that the AND symbol will separate the different types of chemicals or particles in a mixture. Let's think about the differences or similarities between elements and compounds. Let's look at these words, and we're going to draw an E if we think it would represent the word element, and we'll draw a C if we think it would represent the word compound. So first, let's look at these four words. Take a moment to think about whether you would draw an E or a C next to those words. So for this first word, elemental, it contains the word element. So that one's pretty easy. It reminds me of element. I'm going to draw an E next to it. For the word piece and the word part, they make me think of a different meaning of the word element. For example, your landscape around your home has different elements. A tree could be one of those elements. The grass could be another element. So for that reason, I'll write an E next to these. The word compound reminds me of combination or mix. So if I have a union of two things, that sounds like a mix. So I'll put compound. How about these four words? Take a moment to think about whether you would draw an E or C next to those words. For the word combination, I explained when I was talking about union that it kind of reminds me of combination, so I'll just write a C there. Blend sounds like another word for combination, so I'm going to write a C here. Many seems like it could go either way. I could have many elements of something, or I could have many parts that go together in a combination. So I might write E/C here. And then bit. Bit reminds me of small part, so I'll write E next to bit. So elements are defined as pure substances made from only one type of atom. So it looks like we're combining some terms here. So elements are defined as pure substances made from only one type of atom. Compounds are defined as pure substances made from two or more types of atoms. So let's go here. Compound are defined as pure substances made from two or more types of atoms. Now let's think about how this works with particles. Let's circle the two pictures that show a sample of a compound. Take a moment to think about which two pictures you would circle. Okay, as I look at these pictures, if I want to find a compound, I'm looking for a pure substance that contains more than one type of atom. If I look at number 1, I can see that there is only one type of atom, so it can't be 1. If I look at number 2, I'll see that there is more than one type of atom, but it's not a pure substance. I have more than one type of particle, so it can't be 2. 3 only has one type of atom, so it can't be 3. 6 also only has one type of atom, the green squares, so it can't be 6. 5 looks like a good candidate for a compound. It has more than one type of atom, the circles and the squares, and it also is a pure substance. 5 only contains this type of particle. So 5 is good. 4 looks like a good candidate because it contains more than one type of atom, the orange circles and the green squares. and it only contains one type of particle. So it is a pure substance. So 4 is also a good choice. So let's think about this. How are the codes or chemical formulas of elements different from those for compounds? First, let me highlight the chemical formulas for the elements. R represents the element. This one, which we represented with a T earlier, is an element. And this one, represented by SQ2, is an element. And we want to think about the difference between those and the codes we would use for our compound. 5 is a compound. And for 4, we gave that compound the name SQR3 earlier. So it looks like the major difference between our elements and compound names are the use of more than one symbol. In this one, the only symbol used is R. In this one, the only symbol used is T. In this one, the only symbol used is SQ, even though they used the number 2 to show that there were 2 SQs. But in this one, we use an R and SQ. And in this one, we also use an R and SQ. So the major difference in these formulas or codes is the use of more than one symbol. One important thing to note here is that sometimes I use more than one letter to represent one type of particle or atom. For example, when it comes to the R's, I am using one letter to represent the orange circle particle. However, when it comes to the squares, I'm using an uppercase S and a lowercase q to represent one square. So symbols that are a combination of uppercase and lowercase are grouped together to represent one type. I have a single R to represent my single circle, but I have an uppercase S and a lowercase q to represent a single square. This will be important to note as we go on to talk about actual chemicals using their elemental symbols. Here we have some chemical formulas that begin to use the actual chemical symbol instead of a representation of the shape. To make it easier to talk about the different chemical formulas here, let me number them. So I've got 1, 2, 3, 4, 5, and 6. So what I'd like to do now is I'm going to go through, and for every one of these, I want to highlight the different symbols being used to make it easier for me to keep them straight. So if I'm looking at chemical formula 1, I have a capital B followed by a lowercase r, and I know that those two have to stick together because a lowercase is following a capital. So for number 1, that's my only symbol. For number 2, I have a capital N followed by a lowercase a, so that's one symbol. Then I have an H by itself with no lowercase following it, so my H is a symbol. Then I have a C with no lowercase following it. So C is a symbol. And then I have an O with no lowercase following it. So O is a symbol. I'll do the same type of thing for the rest of these. Okay, now that we've identified the different parts of each of these codes or formulas, I should be able to circle the formulas that are elements. So an element has only one type of atom. And what I did first, I went through and circled what different types of atoms were in each formula. So, if I was to circle the formulas that were elements, I would want to find the formulas that only have one type of atom. This one only has one type of atom. It only has one type of color that I highlighted too. I have more than one type of atom, so it would not count as an element. For number 3, each of these parts has more than one type of atom, so I would not count those. For number 4, I would say that these two separately are elements, but all together, number 4 would not count because it combines the two elements. In number 5, the only part contains more than two types of atoms, so that would not count as an element. And in number 6, there is only one type of atom present, so I would count that as an element. So overall, number 1 and number 6 represent our elements. Now let's look at a different question. Let's circle the chemical formulas that are compounds. So remember that a compound is a pure substance that contains more than one type of particle. So in substance 1, there is only one type of particle, the Br particle. So that definitely wouldn't count as a compound. In substance 2, there is more than one type of atom, and it's a pure substance because I only have this type of particle, so I would say that substance 2 counts as a compound. In substance 3, this part contains more than one type of atom, and this part contains more than one type of atom. So separately, I could say that those are compounds, but all together, I would say that this is a mixture that does not count. For substance 4, it looks like there is more than one type of particle, but it is not a pure substance, because these two are mixed together. So number 4 would not count. In substance 5, there is more than one type of atom, and there's no mixture of this particle with another particle, so it's a pure substance. So I would say that 5 is a compound. And in 6, 6 only contains one type of atom, so I would say that it does not count. So our two compounds on this slide are number 2 and number 5. On this slide, I'm going to circle the chemical formulas that are mixtures. So on a previous slide, we talked about how mixtures would use the AND symbol to separate the different parts of a mixture. So that makes this really easy. I only have to go through and look for the substances that contain the AND symbol in their chemical formulas. 1 does not. 2 does not. 3 does. So I want to circle 3. 4 does. So I want to circle 4. 5 does not. And 6 does not. That's all there is for this video. I hope it was helpful.